Hello again. Welcome to instalment 5 in our video series providing best practice advice on geochemistry applications of portable XRF. I'm Todd Houlihan, I'm joined by my colleague Marcus Slate. How's it, Marcus?
How's it, Todd?
Today we're going to be talking about test times. Just how long do you need to test a sample to get the right result? Marcus, how do you answer this question?
Todd, as you know, during this series we've been repeating ourselves a lot, advising on your best practice for field portable X-ray fluorescence. Testing times is a very important part of that. In general, I'd say minimum should be 10 seconds per beam and a maximum of about 120 seconds per beam.
Okay, two things jump out at me there. There's a big range between 10 seconds per beam and 120 seconds per beam, especially if we're talking about multiple beams. And two, what's a beam?
So how about I discuss the question about testing times, Todd, and you discuss the beams?
Genius, Marcus, as always.
So Todd, I'd like to start the discussion about what is actually impacted by test times when using your field portable XRF. It's mainly in relation to precision and lower limits of detection. It's all about statistics. The X-ray is gathering hundreds of thousands of points of information per second. Thus, for some users, a shorter testing time might be applicable, and for others, a longer testing time might be needed.
Light elements, magnesium, aluminium and silica, are harder to measure, aren't they, because they fluoresce more weakly than the heavier elements?
That's right, Dr. Todd. The elements, particularly magnesium, aluminium, silica, in my experience, with a lower atomic number, we need a longer testing time to test at or near the limit of detection for our analyzer. Can you please explain how the beams are optimised on our analyzer?
Sure. What's a beam, or a beam setting? Using different beams allows us to optimise the instrument for different parts of the periodic table. A beam is comprised simply of the voltage of the X-ray tube, the current across the anode of the X-ray tube, and some filtration that we position in front of the X-ray. With these three things, we can optimise the analyzer for different elements, and our systems utilise options of 1 beam modes, 2 beam modes, or 3 beam modes, and that's all going on in the front nose of the analyzer.
So Todd, how about we show the users now exactly how it works in geochem mode, which uses 2 beams?
Let's do it. Okay, to see which elements are measured by which beam, from the main screen we can swipe down from the right and tap on Element Suite, and here's where we have the information for this geochem 2-beam setup that we have. Beam 1's measuring at 40 kilovolts, it's optimised for those elements. Beam 2's running at 10 kV and is optimised for these elements. So it's important you know which elements are optimised for which beam, so that if we need to make changes to the test time, we simply can do that by changing the test times in here. And then back to the main screen and we're ready to take a test. It's that easy.
So another way I like to show customers very simply how to achieve the optimum testing time is by a simple XY graph, with X-axis testing time and Y being the precision of XRF. Obviously, as you can see here, precision improves over a longer testing time, but the customer actually needs to find their sweet spot. Could be 120 seconds down here, or as little as 10 seconds sort of down here. Now let us show you an example within Excel of a customer achieving their optimum testing time for their project.
Okay, here's an example of a customer who's done an orientation survey to optimise their test times under different scenarios, 90 seconds, 45 seconds and 15-second tests. Marcus, you know more about this project than me. Tell me more.
Well, Todd, interestingly enough, if we look at the comparison graphs, we have a heavy element and a light element. As we stated before, sometimes you need a longer testing time for particularly light elements, magnesium, aluminium, silica. If we look at the correlation coefficients for both of those elements along the testing times, if we go from 90 seconds to 45 seconds to 15 seconds, we see the correlation coefficients don't actually change that much. Hence, the customer is getting higher throughput and achieving the data results that they are after.
I see there's a little bit more scatter on the 45 and 15-second tests over the 90 seconds, but they were willing to sacrifice that for the benefit of shorter test times?
They were, Todd. All they wanted was faster throughput to get more tests in the day and faster, quicker results back to the laboratory for quicker turnaround times.
And better productivity.
Indeed.
Good. And that's really the key message, right?
Yep, not every methodology like this is going to work for every customer, but the customer has to go away and do this geochem orientation survey to work out their optimum testing times that work for them.
Yeah. Okay, Marcus, how should we wrap this one up? What's the message?
So Todd, as you've just seen from that example, a customer should always start with a long testing time and then bring that testing time back to a point where they're comfortable with the data quality they're achieving.
It's not rocket science, is it?
No, it's not, Todd, but a customer does need to take the time to work out what's optimum for their project.
Just a little bit of work at the beginning, right?
Indeed, Todd.
Okay, next time we're going to talk about sample containers and the effect on the accuracy and precision of the XRF when you're using different sample containers. So hopefully you can join us then, and we'll be seeing you, mate.
See you again, Todd.